I won't see you in the class on Friday of this week, Monday of next week, or Wednesday of next week. And all three of these dates were already on the class schedule, that it's going to be a recorded lecture. So if you've been following along on the class schedule, this isn't a surprise, but I wanted to mention it anyway. We won't be meeting until Friday of next week. And I wish it was for some fun reason, like I was going to France, but I'm not. On Friday, I'll be over at Heritage Village. Is it called Heritage Park, Heritage Village,
Heritage Farm,
Museum, Farm?
Heritage Farm and Village Museum.
So we'll be there for a strategic retreat that all of the professors and the dean is having. So that's Friday. And then Monday of next week, I'm conducting an ABET evaluation of another university as a program evaluator. So I'll be going through and looking at their curriculum and auditing transcripts and all that sort of thing. So I won't be here because I'll be involved in those. I'll be here. It's a virtual visit, but I'll just be in Teams meetings Monday through Wednesday. So the videos will be posted online on my YouTube channel. I'll have the links in Blackboard, and I'll also email you the links exactly like we handled it with the first week of classes. So you'll just watch the videos, go through the in-class exercises. The solutions to the in-class exercises will be incorporated into the video. And then I'll still be accessible by email, or if you want to call me on Teams if you have questions as you've gone through those activities. So any questions about the next 3 class meetings, this announcement related to scheduling? All right, next, homework 4 is due Monday. So it's Wednesday now. And I'm going to show you some things with the spreadsheet today that'll enable you to solve this next homework assignment. So after today's class, I think you'll be in a pretty good position to complete homework 4. All right, so we're continuing some use of Microsoft Excel. This is chapter 3 in the book, where we begin to use spreadsheet functions for finding present worths and future worths. And we got our first taste of it in the last class meeting, where we, in the second in-class exercise example, solved for an unknown number of years until the project breaks even. Now in that example, someone spent $60,000 and then they got revenue of $8,000 every year. So after you've made that investment and then you get only $8,000 back the first year, obviously, you're still in the red, as they'd say. You haven't made your money back. If you spent $60,000 and you only got one payment of $8,000, and especially because that $8,000 was 1 year in the future, and so it has less value than the $60,000 that you've spent. So break even definitely is not just $60,000 divided by 8, like the number of years until the same number of dollars has been collected. But what we want to know is, when is the same value of dollars? And so that crossover point that we found in this example, either with the table method or with the spreadsheet approach, where we found out how many years until your cumulative balance is positive. So we'll revisit this in future class meetings, this cumulative balance approach. But I wanted to reinforce what we were trying to do here with the unknown n. We were essentially finding out, when does a project become profitable? Now remember the weird quirk that Excel has when we're using the built-in PV function, and that is that an outflow is assumed to be exchanged for an inflow some years in the future. So whatever amount you put into the function, it's going to find the opposite, so the opposite sign when it returns its answer. And so if you really want to know just the present value but still keep it as an inflow, then we have to put the negative sign into the function. So that's a reminder of the one quirky override we have to keep in mind when we're using Excel to get things to work out the way we like. Now, the PV function that I showed you in class on Monday, as soon as we press the equal sign, Excel knew it's equation time, that there's going to be some sort of a function that we're drawing on. And these pre-named functions like PV, Excel expects to see information in a certain order. So that the first field, you have to type in the interest rate as a decimal. The second field, where it actually says NPER, that's the number of periods that apply. And then we put in 2 commas to skip over a field that's known as the payment field. And you'll learn how to use the payment field later on. But for now, we're treating each amount we put into the PV function as a isolated one-time future value. And so that's why we put the amounts that are going into the function in this 4th field, which is the future value field. And the minus sign reminds us that we are trying to override the sign change. So a little bit more about this 3rd field, the payment field. If you accidentally put the amount in there, it's going to think that what you're instead doing is finding the present value of an annual series. And so if it's just one amount that you're trying to discount to the present, then that won't work. And let me show you specifically what I mean, because maybe a specific example with Excel open would make this more clear of why we skip over the payment field. So let's say that we have an interest rate of 10%. So I'm going to type in 0.1 just for this quick illustration here. And let's say that we have a known future value. Like in the future, you're going to get $10,000. Okay, so $10,000 in the future, and N is 5. So you're getting $10,000 in 5 years. How much is that worth today? That's what we want to know. So before we even do the calculations, I want to check with you on something. Is it going to be more than 10,000 or is it going to be less than 10,000?
Less.
Less. That's correct. Why is it going to be less?
Because the depreciation of the money over time.
Good. The discounting. Right. So we're taking money from the future backwards in time to the present. It's going to be fewer number of dollars. So in other words, if someone gives you 10,000 in the future, you should be willing to accept less than 10,000 today because dollars today are more valuable. All right, so let's find the future value. I'm sorry, the present value. So let's do the function. Equals PV, okay, now rate. I just click on the interest rate, comma, NPER, okay, so that's the number of periods, 5 years. I'm going to skip over the payment field and minus of the future amount. So what this tells me is that you can either take 10,000 5 years from now or 6209 today, and those two things are economically equivalent. Okay, no big deal. We could have found that with the factor method or the equation method. Excel is doing something that we already knew how to do. That's fine. But what I want to show you now is what if we accidentally didn't skip over the payment field? Okay, so let me redo this formula again, and this time I'm going to put the amount in the wrong place. Equals PV, okay, interest rate, clicking on 10%, comma, number of periods 5, comma, I'm going to put the minus sign in because that's what we do, right? Now I'm going to click on the future value, and now look, it thinks this $10,000 is a recurring payment of which there are 5. So it's essentially seeing, okay, there's 5 payments of 10,000 each. It's going to calculate what's the present value of an annual series. Of course, there's no markers in here today, unfortunately. I was going to sketch out, what this looks like, but you can visualize it. This is find P given A, the way I've typed it here. So that when I close parentheses and press enter, 37,907. So if you put the amount in the wrong field, it's thinking it's find P given A instead of what we really wanted to do is we wanted this to be find P given F. All right, so give me a thumbs up if you understand the difference between the payment field and the future value field. Thumbs up, good. All right, so just again, when you start an equation equals PV, it starts giving you hints. Rate, NPER, number of periods, okay, comma. So then what you have to ask yourself is, the amount I'm about to put in this function, does it happen one time in the year that I want it to be looking at, or does it happen multiple times? And most of the time when we use Excel, we're going to skip over that payment field. So I hope you understand, and we'll give you more practice just to distinguish between those. Okay, so that's the PV. Now what we're going to do is we're going to find the present value of this cash flow diagram. You wouldn't want to do this one by hand, because it would be kind of tricky, right? I mean, you could. If you were going to solve this one by hand, you could take this annual series to year 1, and then discount it from year 1 to year 0. And you could take this annual series to year 7, and then from 7 to 0. Here's just an isolated future amount that you discount 13 years to time 0. Here's another isolated future value at year 14 and year at 116. So, it'd be probably 7 or 8 steps minimum to find the present value of all of this together. But we can represent this cash flow diagram as a cash flow table in Excel, and it's pretty easy. And so let's do that now. I'm going to just copy this cash flow diagram over here into the spreadsheet. Let me start a new tab and Control V to paste the image so that it's there before us. Now if you've got your computer, start it up and follow along. Okay, here's our in-class exercise. You maybe have the papers printed out. This is in-class exercise 10, problem 1. All right, so as we always do, we start by defining the interest rate at the top here. So we'll start off with I equals, and I have to go over to the next field. I can't put the amount in A1 because then if I reference that location, Excel won't know what's a number or what's a text string. So you have to put the number by itself in a different cell. So it's 7%, so 0.07. So you'll notice that this label that's here, that's really just for our benefit. Excel doesn't need to see that. It's just so that we can remember that the 7% up here in B1 is the interest rate that applies. All right, now the next columns we should put together is time, amount, and PV. All right. And we've got 16 years shown in this cash flow diagram. So let's put 16 years in the table. I'm going to change that third column to say PV of amount, just so it's more explicitly clear that what we're going to be applying the PV function to is the amount that's in column B. All right. Everybody with me so far? All right, so now let's put in these amounts. How much is already at time 0? Nothing, because all that we have on the cash flow diagram is this dashed arrow and P equals question mark. That's the indicator that what we're trying to do is find the present value of all these other amounts. So the amount that's already at the present is nothing. All right? In year 1, there's 0. Okay, 12,500. That repeats 4 times. And it's easy to type it in wrong. So you have to have an eye for detail. Close isn't good enough. It's not good enough in computer science. It's not good enough in engineering. The only thing that's good enough is right. So you have to get it right. 0, for years 6 and 7. And then we have an annual series of 15,000. And I'm going to zoom in a little bit more just to make that clearer in the back. All right. Okay, 15,000 in year 10, 11, and then a gap year of 0, now 17,000, and then minus 7,000, then a gap year, and finally 8,000. All right. One of the things that I think makes it easier to see if you've typed things in correctly, if you've typed them in correctly, is to format these as currency, because then it'll put in the commas, right? And if I accidentally did, like, if I was missing a 0, it may not be as obvious if that comma isn't there. So let me go ahead now and highlight the amount and the PV of amount columns. And I'm going to go here and change it from general formatting to currency. And now it's got the commas, and I can see if I've typed in the thousands correctly. I don't necessarily need to see the pennies, so I could reduce the decimal here and just only have it show the dollars. It's maybe cleaner that way than if it's got these unnecessary zeros. But that's a matter of personal preference. All right, so we've translated the cash flow diagram into a cash flow table. Inflows are positive, outflows are negative, and we want to find out this series of payments and one cost in the future, how much is it worth as a lump sum today? You can either take it as presented in these future years, or what's the economically equivalent amount to get right now if your interest rate that applies is 7%. So we're going to use the PV function, and I've showed you how to do that already, so I'm going to pause for a second and give you a chance to apply the PV function. And you're going to be applying it where this is NPER, the row time that you're in, and then the amount is column B, and the interest rate is B1. And remember the dollar signs. You'll want to anchor the reference up here to the interest rate. And you can do that by pressing F4. So let me pause for a second, give you a chance to do that, and then I'll resume, and you can see if you've got it right. So let's follow along. So equals PV, parentheses, now interest rate. I want it to be 7%. I could type in 0.07, but the disadvantage of doing it that way is that then if I wanted to change the interest rate and just see what happens, I'd have to go and change all of those formulas. And so it's just easier for me to click on a location, and then if I want to see what a change in interest rate does, I only have to change it in that one cell. So it preserves flexibility if I click on the location rather than like hard coding the interest rate into the equation here. So I'll click on B1. Now remember, I need to anchor the reference there, because when I drag this formula down, I always want to look in the same location for the interest rate. Like when I drag this formula down, I don't want it to look in B2 for the interest rate, because it's not going to be there. When I drag it further down, I don't want it to look at B3. So I want to anchor the reference, and so I'll just type in a dollar sign before the B and a dollar sign before the 1. And now dollar sign B, dollar sign 1 means no matter where this equation gets applied, it's always going to look in cell B1 for the interest rate. So comma, NPER, number of periods. The amount that's at time 0 should be discounted 0 years. In the next row, it'll take whatever amount is in this field and discount it 1 year. And so it's using the time, that's how many periods it's discounting this single lump sum future value to the present. So that's why we're defining the number of periods. Okay, now skipping over the payment field with a double comma, and then minus of the amount in the future value field. All right, so 0 becomes 0. That makes sense. Now, I don't have to type that equation over and over and over again. I can just drag it by clicking on this green lower right-hand corner downward, and it applies the function everywhere. Actually, I don't even have to do that. It's even easier. Check this out. All I have to do is double-click on that green location. I don't have to drag it down. I just double-click, and it'll do it as far down as there's data to the left. Okay, so it applies the function further downward. Now let's just make sure that all of this is reasonable. So 12,500 in year 2 is worth 10,918 at the present. Okay, that seems, at least we know that we didn't accidentally put the amount into the payment field, right? And that same 12,500, but now 3 years in the future, is worth less because it's being discounted a greater number of years. So from a reasonableness standpoint, these results make sense to us. Now we want to know what's the overall present value. So we have to add all this up, because each one of these amounts is just like this is the 12,500 at year 2 taken to times 0. And then here, the 12,500 at year 3 taken to times 0 is this amount. And this arrow is meant to represent all of the amounts discounted to the present. So what I'm going to do here is I'll do like a total, and the function is equals sum, and I'll highlight all of the values I want to add together inside of that range. And so you'll notice what it says is C4 colon C20. And so that means add up everything from C4 through C20. And I'll click enter, 78,261. And if I want to know exactly to the number of cents, I can increase the decimal and it'll tell me it's actually 78,260 and 55 cents. But earlier I had formatted this to hide the pennies because maybe I just wanted to know the nearest dollar. Let me ask you a question. We had 2 annual series. Why didn't I put these amounts into the payment field? Why did I put them in the FV field instead of the payment field? Because they are annual series after all.
They were only for a certain amount of years, and it was 2 different amounts.
That's right, because it's only for, this is 1, 2, 3, 4 years. Just because the amount is an annual series, according to this method, we're treating each year individually. So don't be thrown off by the fact that it is an annual series, because, for instance, if I had put this amount into the payment field, it would assume that there's 2 payments of 12,500, and then in the next one, it would assume that there's 3 payments of 12,500. So you just have to understand the underlying approach is we're treating each one of these as though it's find P given F. We're just repeating find P given F over and over again. It's like a brute force approach. We're doing find P given F 16 times and then adding together the cumulative present value. All right, so any questions about this approach before we move on? I would suggest you be sure and save your work. These in-class exercises will be useful to you as a reference when you go to do the homework. And so save it someplace you're going to be able to find it. If you've got all of your files for every single class in the same root of your OneDrive, it may get kind of cluttered. So if you haven't already, you could create like a subfolder on your hard drive or inside of OneDrive that's just material from your favorite class, this one. And then down here at the bottom, you can name the sheet. So this is like problem 1, and then we're going to have a second problem, so you can create a separate sheet. So you click on the plus sign down at the bottom there, and this is problem 2. All right, so we haven't got to problem 2 yet, but we will. So any questions about finding the present value with Excel? So the greatest hits of mistakes. Like what mistakes do students really like? Like what's the favorite mistake? Number one favorite mistake is not anchoring the reference to the interest rate. So those dollar signs. Number two favorite mistake is putting the amount into the payment field instead of putting it into the future value field. And then the number three favorite mistake is forgetting the minus sign. So break the cycle. Don't do those greatest hits. All right. There's also a function called the NPV function, net present value. And let me show you how this works. And the one thing I want to tell you up front is you only put future values into the NPV function. Don't put an amount into the NPV function that's already at the present. Okay, so back over here to this problem we were just looking at. I'm going to do NPV. So equals, because this is an equation, NPV parentheses. Now, you can see Excel is prompting us. It says in the first field it wants to know the rate. So our interest rate, 0.07. You can anchor it, but you don't need to here, because it's just going to look at this one time. We're not going to apply it multiple times, row by row. Okay, so comma, now it's asking for values. So what you'd do is you'd put the amounts that are in the future that you want converted to the present. So this 0 is already at the present. But this 0 and everything below it is some amount in the future. So what Excel is doing right now is it's looking at the amount and also the order that things are told to it. So this 0, it knows, is at year 1. The 12,500, it knows that's in year 2, and so on and so forth. So what it's going to do is it's going to automatically find the present value of all of those future amounts. So as soon as I press enter, 78,260 and 55 cents. So it's kind of automatically solved for the present value of the amount. That's the NPV function. You can use it to check your work, but I'd like you to use this full-fledged approach for the homework because you need to be familiar with it for some other techniques that build on this approach. So there are some other methods where the NPV isn't good enough. It doesn't give you all of the data you need for the rest of the problem. So you have to know how to do both. Okay, what about future amounts? So what we've just done is find the present given a series of known future amounts. If you want to find the future amount, the function for that, find f given p, is the equals fv function. So it follows the same format where the first field is the interest rate, the second field is the number of periods. We skip over the third field because that's a payment field, and we put these individual amounts from a cash flow diagram or a cash flow table, we put it into the present value field, and we still have that same negative sign thing to deal with. So what we're going to do for this one, this in-class exercise, is we want to find what's the future value of this cash flow. And in the handout, I tell you that you're going to need some slightly different columns than we had before. So at the top, there's going to be the interest rate thing. So I equals, and what's the interest rate on this problem? 8.5%. Let me paste the cash flow table here. All right, so interest rate is 0.085. All right, so what the thing says is use the following columns. Year, years until year 16, amount, and future value of amount. So year, years until year 16. And by the way, I can make the column wider just by doing this. If you ever have a situation where your numbers are showing up crazy, just as like, did anybody get this? So you just make your column a little bit wider and it'll show the number. If it's just these pound signs, just make it wider. Okay, so problem 2. Years until year 16, amount, and FV of amount. Because what we want to know is if you aggregate all of these amounts forward to single lump sum payment in year 16, then what's the value of that single amount in year 16? So year, we're just going to go like 0, 1, 2, all the way down through 16. Years until year 16. Now, this is a really important thing to understand. And this is, I guess, another greatest hits mistake, is not understanding how many periods forward in time something needs to be compounded. So let me ask you, this $10,000, what year is it at right now?
0.
What year do we want to move it to?
16.
How many years should it be compounded?
16.
It should be compounded 16 periods. So 0 isn't what we want to put in the function. It doesn't need to be compounded 0 years. It's already at time 0. What we're trying to do is move it 16 years into the future. So we need kind of like a secondary time column to use in our equations. So just to drive that point home, let me ask this way. See this 11,500 in year 2? How many years into the future does that need to be compounded?
14.
14. That's right. So there's a pattern here, right? 16, 15, 14. So you can either type it in manually and then continue the trend with this dragging down thing. So any amount that's already in year 16, it doesn't need to be moved at all to get to year 16. So the n, the number of periods, is 0. So you could either do that or equals 16 minus the year that you're in. So that's the other way to get this reverse time column to be calculated. So we've got the years, and then basically the second thing is just how many years is the amount actually need to be compounded to get it to this specified future. Okay, so does everybody understand the need for this second time column? Okay, so take a moment to type in the rest of the cash flow diagram, the amounts. Let's put in the amounts. I won't read them, I'll just do it. So when you've got the cash flow diagram typed in, use the FV function in the same way that we just did with the PV function. And then at the bottom, we want to know the total. So down here, you're going to add everything up to find the sum of the future values. Got it. And remember, the great thing about YouTube is that you can just go, you can fast forward to the part of the example that you want to see. If you forget as you're working on the homework, you can see exactly what the solution was. So equals FV, parentheses, okay, the interest rate. I'm going to click up here and put the dollar signs to anchor the reference to that location where the interest rate number is. NPER, the number of periods. Now I'm tempted. Should I go here or here? Which one? 16, because the 10,000 needs to move 16 years into the future. Okay, so I'm going to click on that one. Skip over the payment field because it's not like there's 16 10,000s that are taken to the future. That's not what the situation is. It's just a single 10,000. So it's not a recurring payment that happens 16 times. No, it's a single present value that is being compounded 16 years into the future. So that's why I put it in the PV field, is because it's a present value that's going to the future. All right, so then I drag that down through all of them, all the years, and sum the range. 3821. Anybody else also get 3821? I see some yeses. That's great. All right, so you might as well get started on the homework because it's this same stuff, and you won't remember it better tomorrow than you remember it right now. So save your work and let me know if you've got any questions. Remember one last time that the classes for the next 3 lectures are online. So I'll email you and post the links to that on Blackboard.
For that second exercise, could you use the NPV equals